Hey everyone, in this video we'll talk about that how we can perform deletion from a binary search tree. Let's start. So in binary search tree, deletion is bit tricky. So we have to maintain some properties for performing the deletion in a BST. So what are those? So let's say that we'll delete a leaf node. So leaf node means these are the leaf nodes, right? So if we are trying to delete the leaf nodes, then what we have to do, we'll simply remove these nodes. So if we don't have any child, then we'll simply remove the nodes. That's all. Let's say that we have a node with one child. So let's say that we have a node with one child. So what we'll do, we'll replace with child node and remove the key node. So what we'll do, we'll just replace this with child node and we'll deallocate the memory. Now the most important portion, that is node with two child. So let's say that we have a tree like this and we will delete this node. So how many child this node has? It has two child. So first one and second one. So if we are trying to delete this node, now what we have to do, we have to find the successor. So what is the successor of a tree? That is smallest node in its right subtree. So which is the smallest node in its right subtree? So this is the smallest node in its right subtree. So what we have to do, we have to replace the value of this node with this node and we will delete this node. So this is how we can perform the deletion from a binary search tree. Now we can do the same thing for the predecessor as well. So for predecessor, what we have to do, we have to find the largest element in its left subtree. So what will be the largest element in its left subtree? That is this one. So what we'll do, we'll simply replace the value of this node with this node and at last we'll delete this memory. So this is how we can perform the deletion from a BST. So it was a primary idea. Now we'll see that how we can perform that in a BST. So this is the BST, right? So in how many ways we can perform the deletion? The first one is leaf. The second one is one child. The third one is two child. So at first we'll see that how we can perform the same thing for the leaf. So let's say that we are trying to delete 75. So it's a leaf node. It doesn't have any successor or predecessor. It has no child. So we'll simply deallocate this memory and we'll set null over here. So at the right of the 70, we have some memory address of 75. We'll simply put null over here. So we'll simply delete this node, right? So let's say that we'll perform the deletion for a node which has one child. So we are done with the leaf. Now we'll see that for the one child. So let's say that we are trying to delete this 20. Now 20 has no child at its right? It's null. It's null. So what we'll do, now we'll just set this 30 over here and we'll deallocate this node. So let's say that we'll take a variable that is temp. Let's say this is h. Now we'll store h over here. Now h will be pointing to the h left. So 30 will come here. So this is how we can perform the deletion for a node which has only one child. So this is the deletion for with one child. Now we'll see that if we are trying to delete 60. So how many child 60 has? It has two child, right? 60 has two child. Now what we'll do, we'll find the successor of 60. So what is the successor of 60? That is 65, right? So let's understand that what is the successor. So if we perform the in order traversal for this tree, it will be 30, 20, 40, 50, 60, 65. 50, 60, 65. So successor has the lowest value in its right subtree. So let's look at this subtree that 65 has the lowest value in this subtree, right? So now what we'll do, we'll just replace this 60 with 65. So we'll replace the node with its successor when the node has 2 child, and you can do the same thing for the predecessor as well. So we'll just put 65 over here, it will be 65. Now what we'll do, we'll simply delete this 65. We'll find 65 and we'll deallocate the memory of 65. So you can see that we haven't violated the property of BST. So we can see that the left of the root node is less than 65 and the right of the root node is greater than 65, right? 70 is greater than 65, 75 is greater than 65. So we are not violating the property of binary search tree. So this is how we can delete the element from a binary search tree. Now we'll see that how we can perform the same thing in code. So at first we have to construct a tree. So if you don't know that how to construct a BST, just click on this video and watch this. So we have to allocate the memory. Now we'll look at the function that how we can get the minimum element of a BST. So if you don't know that how to get the minimum or maximum element from a BST, you just click on this video and watch this. So that is very easy. We'll just go for the leftmost node of a BST. So you can see that if we go for the leftmost node, now what will be the leftmost node of this tree? It will be 65. So this is how we can get the lowest element of a tree or of a subtree. Now we'll see that how we can perform the deletion in code. So at first what we have to do, we have to check that our h is null or not. If our h is null, then we'll simply return that. So if our root node is null, then we cannot perform the deletion. And let's say that we have a binary search tree like this, 10, 25. We are maintaining the property. Now what is the key? Let's say that we'll delete 20. Now what is the root? At first we are passing 10 over here, that is the root node. 20 is greater than 10, right? Key is greater than 10. So 20 is greater than 10, right? Now what we'll do, we'll simply go for the right subtree of 10. So we'll simply pass 8 right and we'll pass the key. So this is how we can check the property of BST. So let's say that we are trying to delete 5. Now what we'll do, at first we'll check that 5 is greater than h data or not. 5 is not greater than 10. Now we'll go for this case, that is else if key is less than h data. So 5 is less than 10. So what we'll do, we'll perform the deletion for its left subtree. We know that we have the 5 at the left of 10 because 5 is less than 10. Now we'll go for the else portion of this code. So it means we have successfully done the comparison. Else we'll check that h right equals to null and h left equals to null or not. So when we'll come to this else case, it means we have found the value within a tree. Now if let's say that 10 to 20, the left of 20 is null, the right of 20 is also null. So what we'll do, we'll simply free the 20 and we'll set h equals to null. Now why I am setting the h equals to null, we'll simply return this h and it will be added at the right of 10. So we'll return null here and it will be null. Otherwise we can have some memory which is not exist. So let's say that here, let's say that is x, we have x over here. So when we'll return this h equals to null, it means it will be replaced with null. So this is how we can maintain the property of a BST. So when it will be null, it means it has no value at its right. Now we'll see that how we can delete a memory with one child. Now let's say that the left is null, we don't have any value over here. Let's say that 10 and 20. Now 10 has nothing at its left, so the left of 10 is null. Now what we'll do, we'll simply put h into temp. Let's say that the address of 10 is x, the address of 20 is y. So we'll take a temp. Now temp will be pointing to this x, right? Now temp has x. Now h is also here. Now what we'll do, we'll put h equals to h right. It means now h will be pointing to this node. So after writing h equals to h right, it means h is pointing to 20. Now what we'll do, we'll simply deallocate this memory. So how we can deallocate that? We can deallocate that using free. So this is how we can deallocate the memory. So this is how we can delete any element which has only one child at its right. So you can see that 10 had a child at its right. So let's say that for this case, what we'll do, 10, 5. So what you have to do, we just have to simply write h equals to h left and we'll deallocate this memory. So how we can do that? Let's say that our right equals to null. We don't have any value over here. We have 5 over here. We'll simply put that into temp and we'll write that h equals to h left. So it will come here and we'll simply deallocate this memory. So this is how we can delete any element from a right subtree or from a left subtree when the root node has only one child. So now we'll go for the most important case for the deletion, that is a node with two child. So as I discussed earlier, that let's say that it has two nodes, 10, 5, 20. We'll delete this 10. We'll find the minimum element of its right subtree. So let's say that 15. Let's make the tree bigger, 15. Now what we'll do, we'll simply find the minimum value from its right subtree. So we'll simply write h right over here. We'll just pass h right, that is 20. So we'll have to find the minimum element from its right subtree. So which is the minimum element? That is 15. So the find min function will return us the minimum element, right? Now what we'll do, we'll replace this age data with temp data. So we'll simply replace this 10 with 15. Now what we'll do, we'll simply delete this 15. So we have to perform the recursive function for deleting this 15. So what we'll do, we'll simply pass the right subtree and the key. So which key we have to delete? We have to delete this 15. Then we'll simply perform the recursive function again. So this is how we can perform the deletion for a binary search tree. So at last what we have to do, we just simply have to return the updated subtree for every recursive call. So you can see that at last we are returning the h. So this is how we can perform the deletion for a binary search tree. So I think this portion is clear. We have discussed about the dry run, we have discussed about the code, how we can perform the same thing in code. Now we'll do the hands-on. So you can see in my screen that type def struct tree, we have constructed the tree, we are allocating the memory of the tree from here. This is the insert function. We have already discussed about that. What is insert function? If you don't know, just click on the I button and watch this video. So this is the function for finding the minimum value from a tree. So this is the function for deleting any element from a binary search tree. At first we'll check that a tree is empty or not, then we'll go for the checking conditions. If our key is greater than the root data, then we'll go for the right subtree. If our key is less than the root data, then we'll go for the left subtree. And this piece of code will perform the deletion when we don't have any child. This is for deleting the element when we have only single child and when we don't have any value at its left, and this is for when we don't have any value at its right but we have some value at its left. So this portion is for deleting anything when we have two child. So at first what we have to do, we have to call the find min function. We'll get the successor, then we'll simply replace the data and we'll again perform the recursive function for deleting that successor. So this is how we can perform the deletion from a BST. So these are the traversal method. If you don't know that how we can perform the traversal, just click on the I button and watch this video. So this is the switch case function. So this portion we have already discussed earlier. So let me compile this code. Let's say that we'll insert 10, then we'll insert 5, then we'll insert 20. Now let's say that, yeah, so at first we'll delete the leaf node. So we'll delete 5. Okay, 2, we'll delete 5. So 5 deleted successfully. Now let me traverse the tree again. So we can see that we have 10 and 20. So how many data we have? 10 and 20. So let's assume that 10, 20. Now it means we have only one child for 10. Now we'll delete 10. We'll delete 10. So you can see that 10 deleted successfully. So what we have within a tree, that is only 20. Now we'll again construct this tree. So let's assume that we have 20. Now we'll insert 10 at its left and we'll insert 30 at its right. So let's say 10 and 30. So this is the updated tree. Now 20 has two child. One is 10 and another one is 30. Now we'll delete 20, that is the root node, with 2 child. You can see that 20 deleted successfully, 30 replaced with 20 and 30 deleted successfully. So I have just written this 20 deleted successfully for your simplicity. So what we are performing, basically we are replacing 20 with 30. You can see that 30 replaced 20 as a root node. Then we are deleting 30 from that existing subtree. So this is how we can perform the deletion from a BST. If you have any doubt, just write in the comment section. See you in the next video.